Hi everyone, welcome to your 2.2 video lesson. Today we're going to be talking about relations, functions, function notation. All right, so there are a lot of definitions today. The first thing we're going to look at is a relation. So this is a set of ordered pairs that are listed together. So we know ordered pairs have an x and a y coordinate. Okay, there are three other representations for a relation. Okay, in addition to ordered pairs, there's table of values, there's a graph, and there is a mapping. Okay, so a mapping uses these two circles where the first is representing the x values and it shows it being mapped to the second circle that contains the y values. Okay, next up we have domain. So we can split aspects of our relation into different groups. So the domain is one group. This is the x values. Okay, the range is now the y's. Okay, so we could collect all the x values together. Those are considered the domain, and then the same thing with the y's for the range. Okay, an inverse is when we swap the x and the y in an ordered pair. So all that means is we switch position. Okay, we do not change their value, meaning they do not go from positive to negative or vice versa. Okay, so we're going to put these three definitions into action. We're going to apply them to a relation. Okay, so here we're given a relation as ordered pairs, and we're going to be asked to state the domain, the range, and the inverse. Okay, so the domain, we said, is just the x values. So we're going to use these curly brackets, okay, and we're giving the set of all the x values. So that's 1, 3, 12, -4, and 7. Okay, and then the range. The range, we're going to do the y values. So again, we're going to use curly brackets, and you do not have to put these values in numerical order. Okay, you can state them just as they're given. All right, and last but not least is the inverse. So we're going to take each ordered pair and we're just going to flip it. So 1, 0 becomes 0, 1 in the inverse. Okay, so that's how we state the domain, the range, and the inverse. Now, it could be given, the relation could be given as ordered pairs, like it is here. It could be given as a graph. It could be given as a mapping. So my suggestion, if you are given it in one of the other representations, first change it into ordered pairs. This makes it a whole lot easier to then state your domain, your range, and your inverse. Okay, so now our next characteristic here, we're getting a little bit more specific now than just a relation, because a relation can be anything. A function now is kind of like a special case of a relation, and this is when each x value corresponds to only one y value. So that means that none of the x values can repeat. Okay, so we look at these. I have a table of values, a mapping, and a set of ordered pairs. If we look at the x values for each representation, and obviously each representation is a separate problem, none of them have repeating x values. So the table 12, 2, 4, and 1, those are all different. Okay, B is a mapping. Okay, and we can see that these are all different, and not only that, but they each only have one arrow. Okay, meaning that it's only used once. If we look to the right in that mapping, okay, we see that there's only one number in the x values, but it has two arrows, and that's indicating that it is used twice, because on part E we have 3, 1 and we have 3, 5. Okay, so for a function, the x values cannot repeat. That's the important takeaway here. Okay, now we get even more specific. When a relation is a function, okay, so this is the first requirement. All right, that we cannot, or that we must be a function, meaning we cannot repeat any x values. Okay, so when the x values are unique and the y values do not repeat, that is something called one-to-one. Okay, so if we look at this table of values on the bottom, this is the same one from before, we already identified that it was a function because none of the x values repeated. Now, once it's a function, we can check the y values. So if we look, 7, -4, 0, and 9, those also do not repeat. And that means that it's one-to-one. So it's a function and one-to-one. Now, when we say that the x values don't repeat and the y values don't repeat, that does not mean that you can't have an x value that also shows up as a y value. So in example C, I have a 1 as an x value and I have 1 as a y value, and that's okay. This is still a one-to-one function. Okay, it just means when we look at the x values separately and we look at the y values separately, they do not repeat within each other. Okay, it has nothing to do with the other set of values. So everything here at the bottom, these are all functions and one-to-one. Okay, so now we have 3 different options when we are classifying. When we're classifying these sets. So it could be a relation, which is any numbers. Okay, it could be a function, which means that the x values do not repeat. Or it could be a function and one-to-one, which means the x's and the y's do not repeat. So we could just label this real quick. A relation is any numbers. A function is no repeat for the x, and a function and one-to-one is no repeat for x and y. Okay, so that's the difference between each of those 3 classifications. So we want to look at all different representations now and decide, are they function, are they one-to-one? Okay, so example number 1. This is a set of ordered pairs. If I look at all the x values, 2, 4, -8, and 10, okay, so far this is a function. And now that it is a function, I'm allowed to check the y values. If it's not a function, you do not even look at them. So 4, 5, 6, and 2, this is a function and one-to-one. Okay, let's look at example number 2. So first check your x values. And I see that 15 has 2 arrows coming off of it. That means we have 15, 7, and we have 15, 9. So since an x value repeats, this cannot be a function And so we say that is just a relation. A relation cannot be one-to-one, so we do not even check the y values. All right, moving on, example number 3. Check the x's first, and those look good. And then I check the y's, and those are also. Okay, and when I say they're good, that means that there's no repeat within each group. So this is a function and one-to-one. Okay, and last but not least, we have a mapping in example number 4. Okay, so in 4, this is a function because all of my x values are different, but when I look at my y's, there are 2 arrows pointing to 0. That means 0, 0 is an ordered pair, and -3, 0. So that means that that y value repeats, so it cannot be one-to-one. So this is a function only. Okay, the last thing we're going to look at is a vertical line test. So we use this for a graph to determine if it is a function. Okay, so by drawing vertical lines all through our graph, we can determine if 2 of the same x values are used with different y's. So if those vertical lines that I put through my graph touch it twice, that means it is not a function because an x value has repeated and it has gone to a different y. Okay, so let's take a look. So here I have 2 graphs. Okay, and we literally just draw vertical lines all throughout our graph. So you can see that each one of these vertical lines I have drawn only hits my graph 1 time. That means each x value is unique. Okay, that means it has not repeated. And so this is a function. Okay, when I look at this second example, I only have to draw 1 vertical line to see that it hits my graph twice. Okay, so the one that I've chosen happens to hit around -2, we'll say, 5, and then -2, -6, something in that neighborhood. So we see that that one x value has gone to 2 different y's. So this is not a function. When it's not a function, we state a relation. Okay, so that is your video lesson for relations, functions, and one-to-one. Please make sure that your notes are complete and you've written